Welcome to another video. In this video, we want to solve a question based on the principle of conservation of linear momentum. Now, before I play with the question, the law of conservation of linear momentum states that in an isolated or a closed system, the total momentum of colliding bodies remain conserved. A liter, when I say a liter, that means alternatively. The total momentum of colliding bodies before collision is equal to total momentum of colliding bodies after collision. So what does that imply? We can now say that if the two bodies are bodies A and B, mass of body A, let it be MA, and let the mass of body B be MB. A body of mass 3 kg, that means MA is 3 kg, then moving with a velocity of 10 meters per second. That's the initial velocity of body A, UA is 10 meters per second. The mass of body B, let it be 3 kg. Okay, the mass of body B is given to us as 1.5 kg. Then, initially, collide with a stationary body of mass 1.5 kg. Since body B is stationary, that means body B is in a state of rest. So, initial velocity of body B is 0. So what does that imply? If the two bodies move together after impact. Now moving together after impact means that we have two types of collision. We have the elastic collision and we also have the inelastic collision. In elastic collision, the two bodies, when they collide, there is an expansion. It returns back to the original position. Both the kinetic energy and the momentum, they remain conserved in elastic collision. An example of elastic collision is collision of billiard balls. Snookers. When snookers hit the board, it returns. That is an example. Another example of collision of gases. It is elastic. But when we say inelastic collision, it's only the momentum that is conserved. The kinetic energy change because after collision, when two cars collide, that is an accident. At the end of the day, the two cars coalesce. When I say coalesce, the English meaning of coalesce means stick together. The two bodies coalesce. They stick together and form a composite body. After the collision, they move with one single velocity, which is called the common velocity. I call that velocity V. So now, find if the two bodies move together after the impact, calculate their common velocity. So this common velocity is what they ask us to calculate, V. So the equation of inelastic collision is MA UA plus MB UB is equal to MA plus MB multiplied by V. So this equation is the equation of inelastic collision, which we are going to use to settle this problem. So now let's plug in those values in this equation. Our MA is 3 multiplied by our UA is what? 10 plus our MB is 1.5 and our UB is 0 is equal to MA plus MB. Our MA is 3 and our MB is 1.5. We multiply by this V, which is the common velocity after impact. 3 times 10 is 30. Plus this multiplied by 0 is 0. Then left with 3 plus 1.5 is 4.5 V. So we want to make V the subject of the situation. So 4.5 V is equal to 30. So V is equal to 30 divided by 4.5. So let me improvise here. 30 divided by 4.5 is 45 over 10. So V is equal to 30. 45 over 10 will now invert. It becomes 10 over 45. So 5 here 9, 5 here 2. 2 times 30, V is equal to 60 divided by 9. So how many 9 goes in 60? 9 is 60, 9 times 6, 54. Points. Now we are left with 6. In 60, when you add 0 to that 6, that gives 60. 9 is 60 again, that is what? Another 6. Then 9 times 6 is 54. Left with 6 again, add another 0, that's approximately equal to 6.7 meter per second. So hence, their common velocity, hence, their common velocity after impact, and say after impact or after collision is 6.7 meter per second. So that comes to the end of the session. Don't forget to like my channel, my YouTube channel, to comment, to subscribe, and my Facebook channel, Chigo Calculus, my WhatsApp channel, Chigo Calculus. So don't forget to like, to share, to subscribe, and all of that. So life is continuous, life is differentiable, life is integrable, but not the best measure.